Hello everyone, this is Yulia Kosarenko and here is a new video for you. Today we will talk about ERDs, entity relationship diagrams, and specifically about the common mistakes that we sometimes make when creating them. Now, I've been teaching students for a few years now, and I've worked as a business analyst for many years before. So whether you're a business analyst, data analyst, student of business analytics, or anybody who has to do anything with data, you need to understand data models and ideally to create at least simple conceptual diagrams. So today we will talk about some very fundamental things that you need to know when creating data models, conceptual data models, high-level logical data models, and I will show you some of the mistakes that we sometimes make and how to avoid them. And hopefully after watching this video, you will say, oh, that's all common sense, which means that the video was successful. All right, so let me share my screen with you and we'll get right into this. Okay, so here is an entity relationship diagram. It's a relational data model, and as you can see, it has a few entities with a couple of attributes. It's not very detailed, so we can't say that it would have all the attributes required to actually model the data for, say, ski resort management system, but it's a start. And we will focus on just a couple of examples, so we don't have to run an exhaustive data model that has 25 attributes for each data entity. We'll keep it simple. And let me remind you once again, we are working on ERDs, entity relationship diagrams. And let's recap the three building blocks. The first building block is entity. Entity is a person or thing or event or concept about which you want to keep data. Something important to business, something important to the enterprise that you need to track, you need to monitor, and you need to have accurate data about. Some examples would be customer, product, order, supply, employee, department, interaction, account, and anything like that. Think about important nouns. The next building block is an attribute. Attributes are characteristics of those entities. That's the characteristics that will distinguish one instance of this entity from another. For example, how do you distinguish one customer from another? By their name or their name and identifier. How do you distinguish one product from another, one order from another? So attributes could be things like names, addresses, phone numbers, prices, colors, sizes, addresses, total amounts, and anything at all that characterizes your entity. And a third important building block is a relationship. Relationships are linked between the entities. They tell us how entities relate to one another. So there is a relationship between a product entity and a supplier entity. Product is supplied by a supplier. Supplier supplies a product. There is a relationship between order and products. Order contains products that you're going to buy. A department is composed of employees. So there is a relationship between entity department and entity employees and so on. So the purpose of ERDs, of data models, is to depict important data entities, relationships between them, and their distinct characteristics. So here is one more our example. So we have 7 data entities here: ski resort, summit, lift and run, facilities of a ski resort, lift pass, and the season for which lift pass is valid. So these are just a few examples. And each of these data entities, of course, will have multiple attributes. Here I just have a couple of examples: resort name, summit name. For a run, I'll have run name and difficulty, easy, medium, hard perhaps, or green, blue, and black. My lifts will have names and types. Is it a gondola? Different facilities, and then lift pass, there may be different types of passes, perhaps seasonal, daily, evening pass, weekend pass, and usually a pass is designated for a specific ski season. So this is just a simple example. Now, even with simple data models, beginners sometimes make mistakes, and the goal of this video is to review those mistakes with you and help you to make less of them and avoid those mistakes in the future. So let's start with mistakes we sometimes make when naming entities. data entities. Remember, entity is something business wants to keep data about. First of all, cryptic names. We want our names to be easy to understand. This is not a really good entity name. A much better name would be customer. Very easy to understand for anyone looking at the data model. Another example, here is entity 123. What does it mean? It's just a number. A much better example would be location. So always use nouns that represent real-world facts or objects, such as location, account, customer, product. This is much better than any cryptic name or abbreviation. Next mistake, plural. Using plural nouns. When we name our entities, products is not correct. More precise and more accurate is to use singular nouns because entity represents a type of thing. So we always should use singular nouns such as product, not products. Another mistake, using too many words. For example, using long noun groups. We sometimes create more confusion with using so many words. Order, tracking, entity. Words tracking an entity really aren't necessary. It's much easier to minimize the number of words, aiming for one, of course. For example, in this case, you can just call your entity order, and it's clear enough. Another mistake, being too specific or categorizing your entities. So if you're, for example, tracking information about schedules of public transit and tracking all the transit stops, having a separate entity for permanent stops, temporary stops, and on-demand stops doesn't really make too much sense. It's just too categorized. What would be easier and smarter and more elegant is to use a generalized entity, stop, and have this category as one of the attributes. So my entity would be stop, and different instances of this entity may have different value in their attribute category. Some would be permanent, some temporary, and some on demand. But if all the other characteristics of stops are the same, it's just category that is different, we can consider them the same entity. And our attributes are designated specifically for this purpose to distinguish one entity from another by their characteristics. Moving along, confusing state with entity is another interesting example. Here, if you look at these four entities, new order, completed order, canceled order, and pending order, these are just four states in which you can find the order. The order, for example, that you receive from the customer as an enterprise. So new, completed, canceled, and pending are just different states that order can be in. And again, from data modeling perspective, from conceptual data model, and that's not the right way to do. That's not the right approach. It creates too much clutter, and we are still talking about the same order. So a much better way to do it would be to use a generalized entity, such as order, and introduce state as an attribute. So you will have multiple instances of the order, and they'll have different states. Some of them will be in state new, some of them will be completed or canceled or pending, but again, all the other characteristics of those instances would probably be the same as in any order, such as who's the customer, what's the order amount, what's the date, etc. So order is good enough in this case. Moving on to typical ERD mistakes we make when defining attributes. Attributes are characteristics of our entities. It's how we define, describe them, how we distinguish one instance from another. So sometimes we are so focused on figuring out what are the right attributes that we miss the most important ones, names and identifiers. Here in my entity customer, I was thinking of customer address and email and phone and perhaps added customer category and all different pieces of information I want to track about customer. And I forgot something important. If I have one customer called Riley and another customer called Rena, how will I tell one from another? At the very least, I need to track customer names. So most of the time, entities need some kind of an identifier or a name, and usually both. So for my customer, it's always a good idea to have customer ID, which we usually try to keep unique, or primary key as we say, and a customer name. Of course, in real life, you often distinguish first name, last name, middle name, and so on. But at the very least, remember that entities need to be named, and usually they need identifiers to make all of our data management much easier. And in this case, for example, in my table that I will, where I will keep data about my entity customer, now I can easily tell which row belongs to Rina and describes Rina's characteristics and which row describes Riley's characteristics, because I have customer ID and customer name tracked as attributes. Moving along, missing time attributes. Time is another important attribute, almost as important as name. In this case, my entity is complaint, and I see that we are tracking who's a customer that made the complaint, what's the complaint identifier, complaint reason, resolution status, but when did this complaint happen? That a little bit piece of information, which usually is important whenever we are processing complaints, which are events, it's missing here. So any time-bound entities, and often we call them events or transactions, need date and time attributes. It's critical. So in my case, what I want to have is a date when complaint was received. Often we even track more than one date. For example, when it was received, when it was resolved, etc. But some kind of date and time element is necessary anytime our data entity is an event or transaction. Here is another one. And this one happens more often than you would think. And sometimes it's hard to explain to someone who is new to data modeling, but it's so important to understand it, to get it right, because when you understand it, you understand data modeling better. So we don't want to confuse attributes with values of attributes. So in this case, my data entity is pizza. So imagine I'm making pizzas, I'm selling pizzas, I have my pizza identifier, and then I have attributes like Neapolitan, Chicago, Sicilian, New York. So these are all different types of pizza, right? But they don't belong here as attributes. What they really are, they are different values that the same attribute pizza type can take. So consider this. You have pizzas that you are baking and selling to the customers, and about each pizza you can define what type it is. It's either Sicilian, or it's Chicago, or it's Neapolitan. It could not be all of them, right? So it's really a pizza type. And perhaps if you're a really sophisticated pizza place, you may be able to bake so many different pizza types. So a really pizza type is an attribute of your pizza, and its value can take on various examples. So in the world of data modeling, we would usually expect this to be two different data entities. One entity representing pizza, and here, of course, you can have more attributes than just ID and type. The type of pizza will have one specific value out of the whole list of possible values. What are all of the different pizza types? And you will know that Sicilian actually is rectangular, and I learned it while making this video. It's made with ship's milk cheese. The Chicago pizza is a deep dish pizza. Neapolitan is usually round and has to use creamy mozzarella, and so on. So different types of pizza can be described, and then pizza data entity, its attribute pizza type, will take on one of the possible values. All right. And usually what I say, for example, to students when we are reviewing diagrams and we have this case like this, I say, imagine what if you had 1,000 possible values here. For example, if this was a city and you have 1,000 possible values, do you really plan to have 1,000 attributes in this data entity? So this is a very typical beginner's mistake. Moving along, let's talk about mistakes with relationships. Relationship is how one entity relates to another? What is the link between them? When we learn to draw entity relationship diagrams, and we create those relationships between entities, for example, between customer and order, we assign cardinalities to these relationships. For example, in my case here, a customer can have one or many orders. This is what this notation stands for. What's important to remember is that a relationship is two-sided. So this is just a one-sided cardinality, which tells me how many orders can relate to one customer, but it doesn't tell me anything the other way around. What about the order? Can it belong to only one customer, to multiple customers, or could we have an order without a customer that doesn't belong to anyone? So that information is missing here, which would make this model incomplete. So what we need is we need to add cardinality on the other side of this relationship. So always remember, relationship has two sides, and very often it's not symmetric, which means they're different. Very, very frequently what you will see in data models is this asymmetric relationship, which we often call a parent and child relationship. In this case, customer entity would be a parent, and it could have could be related to multiple orders. So we can consider order like a child entity. But the order itself can be associated with one and only one customer. You always need to know who ordered this particular pizza. And in this way, it's a parent and child entity, so the cardinality is different. All right, so what else do we want to cover today? Confusing parent and child attributes. That's another very typical beginner mistake that we want to avoid. So considering further our relationship between customer and order, if we start to develop some attributes for customer and for order, what sometimes I see beginners do, because they know that customer will have orders, they will put the order ID attribute into the customer data entity. And that doesn't make sense, and that's wrong. Because if a customer can place multiple orders, then how can any specific order be a characteristic of a customer? And this is just one attribute, but my customer can have multiple orders. So what we have here is we are mixing up where is this link between parent and child supposed to be. And where this link is supposed to be is with the child. The child entity, which is order, needs to have an attribute linking it to a customer. And for those who are familiar with concepts of keys, we also call it a foreign key. So my order entity needs to have some information about who's the customer, which customer this order belongs to, because an order belongs to only one customer. And that's where this attribute belongs, customer identifier, with the child. So this is the right way to do it. Foreign keys usually are placed in the child data entity, and they establish relationship to the parent, in this case to the customer. Here's an example now. We have in a table customer, we just list information about our customers, Lily and Lenny. And then my table orders will have all of the orders indicating which customer each order belongs to. So I see here Lily has one order and Lenny has two orders here. All right, another very interesting and very critical mistakes to avoid is missing one-to-many relationships. Now, when we miss one-to-many relationships in real life, when we are modeling data, for example, for a new computer system, that can really wreck our design and cause a lot of rework and a lot of headache. And it starts with modeling. We might, if you miss it during the modeling, someone else may miss it further down, and then it creates more problems downstream. So in this case, you can see someone started modeling data entity called employee. And we figured out that employee has an identifier, name, and email. And then, employee will also have performance reviews. here is anytime you think about something in plural, that should be your red flag. Anything that exists in plural possibly indicates a one-to-many relationship. In this case, we are practically saying here that employee can have multiple performance reviews, and we know, of course, from real life that that's the case. But whenever we discover anything that where one thing can have many relationship with many others, this is a typical parent and child relationship. So here is the thing: the one-to-many relationship needs more than one data entity. You can't cram multiple children into your parent entity. That would not be correct. That would kind of defeat the whole purpose of data modeling. If we have one-to-many relationship, we need to say between which entities these relationships exist. So in this case, employee entity has a relationship with a performance review entity, and it is a one-to-many relationship because one employee can have one or many performance reviews, but a one particular performance review is done for a specific employee. So very similarly to previous example with customer and order, this would be a parent entity and a child entity, and a performance review will have a indicator or attribute indicating which employee this review is for, and then possibly some other attributes such as date, because remember, this is an event. This is something that's linked to a specific period of time. So performance year, review date, and maybe review score and comments and anything else that needs to be tracked about the performance review. And then one single employee. For every year when they had a review, there will be another record in this other data entity. So be very careful not to miss one-to-many relationships, because that can create a lot of problems. And finally, another mistake that sometimes happens, and sometimes it happens because we use someone else's data model and modify it, update it, or maybe open it in another program. And that issue is with mixing up modeling notations. So in this case, I have cardinality on both sides of my relationships described using two different notations. Notation on the left, UML, and notation on the right that we call crow foot. And both of them can be used, but not together. When we do any type of modeling, we need to be very careful to use consistent modeling notation so that our diagrams are not confusing, they're clear, they're easy to understand, and they look professional. So it's true that there is more than one notation to show cardinality in entity relationship diagrams, and you can use whichever one is used in your company, or whichever templates are available in, for example, in the software that you are using. However, do not mix them up. If you use crow foot, then use it throughout your whole model or set of models. If you use UML notation, then use that everywhere. Don't mix them up, because it creates more confusion and it's totally unnecessary. Other ERD mistakes, and of course this part of the video can go on and on and on, but I'll just show you one more mistake, and perhaps we'll have another video later on with more examples. This mistake is confusing metrics and attributes, and again, I see it very often, and it's just something that we need to really understand why this is not the right place for this type of information. So in my customer entity, I have attributes customer ID, customer name, and number of orders. And that happens when we are thinking about these important metrics that we kind of know in advance that we will want to analyze and track. But consider, number of orders is not something that is stable. It's not a stable characteristic of a customer, such as their name and address. Number of orders is going to change with time, right? And it really is a metric. It's not an attribute. So what you have to remember is that attributes, those distinct characteristics of entities, they're usually stable. Yes, they may change. Your address may change once in a while, but they're relatively stable. They define your customer. They distinguish one customer from another. Metrics is something that we calculate, and usually it's for specific time frames. So the number of orders that customer has can have so many interpretations. Is it total orders? Is it this month? Is it this year? Which orders? Is it only completed orders? Is it only orders that weren't returned or canceled? So metrics usually require a lot more definition and business rules. And more importantly, they are usually determined for a specific time frame, and they change with time. So let's look now at this example. We have a customer entity. So we have here Lily and Lenny and their customer identifiers. We have an order entity and a table where we will track different orders placed by these customers. For each order, we will have their dates and amounts and so on. And imagine you can have data for many months here and for years and for all of your customers. Now, of course, if you are an enterprise that is interested in how well you're doing in sales and how your customers place in orders, maybe you will want to have some reports or dashboards or some kind of analytics that will provide monthly summaries of customer orders. And that monthly summary, for example, might include number of orders per customer, total order amount per customer, and per month, right? So a summary report could be grouped and aggregated so many different ways and based on many different dimensions. In this, my example here, there are two dimensions, customer and month. So this is my number of order per month. And you can see here, Lily had 2 orders in January. And Lenny had 4 orders in January. And then Lily had 5 orders in February, and Lenny had 0, and here are the amounts. So these metrics make much more sense when they're part of our descriptive diagnostic analytics dashboards, part of the business analytics. They are not really part of the data entity itself because it's fluid, it changes with time, and it requires a lot of different definitions and explanation what it means. So I will finish with just this particular example, and I'll be happy to hear of any of your questions or any other examples of typical mistakes that perhaps you've encountered or you've made yourself. Perhaps we will have enough for another video, but I hope that this gave you a good idea, especially if you're just beginning to dabble in data modeling, of those mistakes that are, I guess, easy to make when you are just at the start. But as you do those diagrams more and more, and more importantly, look at the examples of the diagrams done by professionals, you will start to see and feel what makes sense, what doesn't make sense, what looks right, what doesn't look right. Because even a simple conceptual data model, when it's done right, can be so powerful, can be a great communication tool, explaining data, explaining relationships with data, and discovering new requirements, discovering things that may have been missed. Because when you put it in a picture, when you put it in a diagram like that, suddenly you have more questions, suddenly you may see things more clearly. But those little mistakes, when they creep in, they make your diagram confusing, hard to understand, and then nobody wants to use it because it's just weird or it's just muddled. And that's not what you want, right? You want clarity, consistency, and conciseness. So I will finish here. I'll post in the links some of my article links, especially those related to model and best practices, and also some of the videos I have that show you how to create conceptual data models. Best of luck. Enjoy data modeling. Let me know if you'd like to learn more about any types of diagrams, and take care. Until next video.